with Solace. There you go.
All right, hello everyone. My name is Jamieson. I'm a solutions engineer with Solace, and today I'm here to talk to you about event-driven APIs. Are we there yet? Freeing our apps from endless polling with event APIs. So I don't know, for those of you that were in the keynote this morning, Alyssa made a joke about API security being an onion, and in Shrek they make the joke, ogre's like an onion, it's got a lot of layers. Also from Shrek, there's this joke where Donkey's on the back of their cart after their wedding, and he keeps asking, are we there yet? Are we there yet? And I don't know if you guys have kids, but if you go on a road trip and they're constantly asking you, hey, are we there yet? Are we going to stop soon? Wouldn't it be better if you could just turn around and let them know when you do get there? It would free up a lot of time for you, a lot less headache. Well, this is something that's possible now with event-driven architecture. Instead of constantly having to pull REST APIs to find when the information that we want is ready, we can advertise a subscription to that information. When that information is ready, the broker will publish that to us, and we can execute on that information. So today I want to talk to you about where we are at with event-driven APIs and the tooling around those APIs, and how we can transform our infrastructure into event-driven APIs and drive value with that. In order to do that, we are going to take a look at an example architecture, look at that architecture transforming into an event-driven architecture, take a look at the tooling that has enabled us to do this, and then take a look at how we can use that tooling to drive value with event API products. So to set the stage and make sure that we're all on the same page, what is event-driven architecture? So event-driven architecture, or EDA, is a decoupled means of asynchronously communicating between publishers and subscribers. This communication happens over a broker or is brokered via an event router. We often just call this the broker. And it allows our publishers and our subscribers to not really know about each other. They just communicate with the broker instead of directly with each other. This allows us to build much more robust ecosystems of applications. Now, what is an event that we're passing across this broker? Well, events are blocks of information which represent a change in state or an update. And these events are immutable, which means that we don't update an event. If something changes, we're going to issue a new event with that updated information. So hopefully, now that we have a groundwork for what an EDA is, we can take a look at a example architecture here for a theoretical medical office. This is a synchronous architecture, so leveraging REST APIs. On the right, sorry, I thought we went to the next slide. On the right here, we have a bunch of internal stakeholders. So these are folks interacting with these applications on a daily basis. These applications may be for issuing lab orders, getting patients into rooms, scheduling appointments with patients. Typically, this would either happen directly with communication between the apps that those people are using and the services on the back end, or that would be brokered via an API gateway. Using the tooling that we have for APIs, we're able to share this information with external parties who are interested. So these parties could be an app that the patient's using, maybe a ride-sharing service that helps patients that are no longer able to drive get to the hospitals or the doctor's office. And then those apps are also able to respond with information into this system. So this works all fine, but then the big, bad, event-driven ogre comes along and says, hey, we need to make our applications more real-time. We want to take advantage of this information right away when it's happening and provide a better experience for our patients and those third-party external consumers. So we're going to re-architect this entire system as event-driven or asynchronous. So the re-architecting of this is relatively straightforward. We replace our API gateways or our applications with brokers. The applications are going to communicate via the broker, or in this case, a mesh of brokers. Our internal stakeholders will access those events via the mesh. But now we've alienated all these external folks. So we've spent all this energy and time re-architecting our internal infrastructure so that it's better for us. We get information in a more timely manner. We don't have to continuously pull and ask for that information when there's an update that gets pushed out to us. But how do we share that information with third-party or external services that are interested in that information? Well, we have the ability to do that right now. We could place a broker outside of our network here. We could intelligently integrate that broker with the existing mesh inside of our network. And now all of our third-party stakeholders out here could subscribe to events on that particular broker and have access to that information. But by moving away from REST APIs or synchronous APIs, we've lost access to a huge toolbox of resources that we would have previously used to govern and manage and expose those APIs. So as Gardner says here, architects have to look for a new approach to handle this so that they can take advantage of what event APIs are enabling, because the existing tooling may not be sufficient. So let's take a look at what is the existing tooling and what's come along for event APIs that allow us to accomplish the same thing. So in a RESTful architecture, we have an API gateway. Now this handles the runtime aspect of the APIs, so connecting the clients to the providers and ensuring that that connection is monitored and is happening in the way that we would like it to happen. On the top half of this circle, we have the design time aspect of RESTful architecture or synchronous APIs. And these are developer portals. They allow us to catalog and document the APIs that we've exposed, understand what APIs exist inside of our organization. We can share those APIs both internally and externally and drive additional value from those APIs. And then it also allows us to analyze those APIs and extend them so that we can continue to iterate and create new value from those APIs. It also has additional design and code generation benefits for the developers. On the event-driven side of things, we have event brokers, which are handling these runtime operations, connecting the publishers and the subscribers, ensuring that we're meeting our SLA uptimes and all these things, but there's a huge missing component in the top. What about all these tools that we get from an API portal? So then we have event portals, and these are relatively new. These bring all of these tools that we're used to in the API portals to event-driven architectures. So this is a place that you can go to design and catalog your event-driven architectures. You can run discovery against existing event-driven architectures, and then share that and document that information inside your organization so you don't have multiple places around the organization re-exposing the same events, cluttering up your infrastructure, maybe not securing it properly. And all of this allows us to analyze and actually understand what's going on with our event-driven architectures. So now that we have access to this information and to design and govern this via an event portal, how do we use that to actually drive value from these events? I believe there are a couple of steps towards realizing the value of an event-driven API. It starts with designing and discovering. So as we know, we actually have to have events to be able to get value from them. Once we have those events, we need to be able to look at them and determine what is the value of these events, who are they usable to, and why will they be valuable to those people. Then we can take those events and build documentation around them, combine them into curated groups of events, and actually expose them to those particular groups that are interested in using them. Those can be internal and external groups that would benefit from these events. And then finally, once we've exposed those, we need to manage them. So we need to keep track of who's using them, are they accessing it securely, and then we need to continue to iterate on and evolve those event API products. So I'm going to walk through the steps involved or what each of these components look like in an event-driven architecture, so you can draw parallels between what you've been doing in synchronous APIs and what you do with an event API in the next few slides. So that first step of design and discover, I'm not sure if you guys are familiar with things like Apigee and these other toolboxes around RESTful APIs, but initially, you need a place that you can get together with your architects and create and manage your events. So what this involves is laying out which applications are going to consume events, what are the events that those applications are going to consume, what are the schemas that are going to be transmitted on those particular events. All of this can be designed and laid out inside of an event portal. You can also do discovery against an event portal. So say that you have existing Solace or Kafka or Software AG event infrastructure. You can run scans against these infrastructures and then bring them into your event portal tool in order to understand what is actually happening inside of my event-driven architecture. You don't want it to be a black box where nobody knows what's happening. They're like, oh, just connect and consume this one event. And you're like, well, what else is going on there? So by having this place where you store your designs and you discover what's going on inside of your organization, it helps to shed that light on the event-driven architectures. Once you have made this investment, you want to make sure that it's accessible to the entire organization, and then you can derive value from those events. So we can do this with a catalog. So inside of an event portal, you'll have a catalog, which allows you to go through and see what events exist out there, what architectures are they a part of, and then also how do you get to them. So once you've exposed these events internally, there's a lot of folks who aren't a part of the design team or aren't developers on your particular teams that need to understand what exists inside of this organization. There's also developers elsewhere in the organization that may re-expose events if they didn't have a place that they could go as a single source of truth to find out what events have already been exposed. This can create a lot of clutter. It can lead to exposing information that's not secured properly. So by having a catalog, you get to have this single source of truth where you can go and say, okay, this already exists, here's how I access it. Or, okay, it doesn't exist yet, so my team's going to expose this information as events, and then the rest of the organization can take advantage of that. Once that information is in the catalog, how can you drive value outside of your organization? Well, we can do this by curating event API products. So if you're familiar with synchronous APIs, you can create API products. And this is a nice packaged product of certain APIs that an organization believes will have value to certain stakeholders. So they can provide these stakeholders with that API product, and it's an easy, consumable way for that particular stakeholder to get at the information that they're actually interested in. And we can do the same thing with events via event API products. So you could go through your event catalog and select events that are going to be valuable to a particular stakeholder, bundle those up together, and then expose those high-value events to your internal and external stakeholders. I have a couple of examples of what that might look like, given our, oh, it doesn't look great on the screen here, but given our earlier healthcare examples. You may have someone who goes into the doctor's office, and the doctor would like to get some more information about this patient. So to do that, they are going to issue new orders for this particular patient. They're going, in order for to get this information, they're going to have the patient give a sample of some kind. That sample is going to have to be processed, and then those results will eventually be available. So these are our events. We think they're going to be valuable to the external labs. So we're going to combine those together into the new lab orders event API product. We can then expose this event API product to the lab. The lab team can go ahead and export that event API product as async API spec. So this is code spec for that particular API product. And then they can generate code around that using the code generators that are developed and maintained by the async API community. And this can give them a head start on the development of the app, can allow them to maintain synchronicity with the updates to the spec inside of those events. So there's a couple more examples that I have here. We now have those results available events, results reviewed events, and patient order events. These are technically all lab results. So we are going to bundle these up as the lab results event API product and make that available to physicians. Some of these events are going to be published as part of this product, and some of them will be subscribed to as part of this product. And in an event API product, you can specify whether an event is going to be published or subscribed or both. This is part of the management of an event API product. And those would be valuable to physicians or maybe nursing assistants, medical assistants, as they're actually communicating with the patient. Finally, patients are going to be interested in the results from their lab. What do they have to do because of the results of their lab? So we're going to take these orders from the physicians, these are patient order events and new prescription events, and package them up as patient lab results and orders, event API product, and make that available to pharmacies and patients. So what does it actually look like when we expose these event API products? For those of you familiar with Swagger, this may look really familiar. This is an event API product powered by Async API. So here we have the different channels that this particular one is publishing and subscribing on. Sorry, I didn't remake this for healthcare. This is our Acme rideshare example, but you can see there's 4 channels here, and they are topics. So this is how we will publish or subscribe particular events, is via these topics. If I were to actually drill into them, this would give us information about what's the payload of this topic. What do each of these values in this hierarchical topic string mean? Where am I going to go to actually subscribe and publish to these topics? And then what is the payload or the messages that will come across in those events? And when you find this page, you can actually download all this information as a spec, the Async API spec, and run that through code generators as well, so that you can automate this entire process. It's not going to be a manual process every time. So that would be the exposing via Async API. Finally, we want to manage how these event API products are used. So this is what it looks like when we expose an event API product in my particular company's event portal, Solace. But we get to specify, for these particular events, how are they going to be used? Can people publish to them? Can they subscribe to those particular events? Can they do both? Maybe if these are patient orders and the event API product is for a doctor, they will want to subscribe to those new order events and publish them, whereas the patients would only get to subscribe to those events in their version of the event API product. So all in all, this is the way that we are able to drive value from events inside and outside of our organization in a similar way to what we've come to expect with synchronous APIs, except now we get to do it with the speed and the asynchronous ability of events. If you'd like to learn more about how this works, my coworker Himanshu is giving a workshop where you actually get hands-on with this information and get to play around with Solace Event Portal. You'll understand better how we design this stuff, how we create events in the catalog and curate them into event API products. And that's happening in Hub 2 at 2:30. I put 2:55 here. The schedule got updated since I made these slides. So 2:30 in Hub 2. And I think that would be a really great experience if this is something that you're interested in or your company is moving towards. And then just as a final note, the reality of the world that we live in is that we're going to have both REST APIs and event-driven APIs inside of our organization. Some things are better off. I want to ask a question and I want to get a reply to that on my terms. So that's where these REST APIs are going to come in. Maybe customers interacting with an online portal or an online site. And then there's going to be, and that'll be supported by OpenAPI. And then if we have things that are better done asynchronously, so it doesn't need to happen right now, I get the response when that information is available. That will be driven by event-driven APIs, publish and subscribe model. And then all of those can be the stakeholders will interact with that via Async API. So that's my presentation. We are giving away a Lego gauntlet. If you guys are here and you haven't had your badges scanned, these lovely young ladies at the door will scan you on the way out, and you have the opportunity to win that Lego gauntlet. But that's it for my presentation. So if you have any questions, I can field that now. Yeah, absolutely.
Here, let me give you.
We have a mic. It'll come up. Yeah.
Thank you. Question about security. Since we all hear about security, how do you ensure access entitlements? So this certain subscriber can subscribe to certain publication. Let's say I'm a rideshare provider in your example. I may need to have access to scheduling because I need to know when to bring the patient, but by no means I should have access to the lab test results.
Right, okay. Can you put my slide back up on the screen? Is that possible? I'd like to speak to it. Okay, so in this particular example, so you're out here, and you need access only to the information that you should have access to, and not all this internal information. So we have the ability, at least I can speak to Solace, the ability to control who has access to that information based on RBAC, so role-based authentication. Based on your role, you'd have access to the information that's relevant to you. So maybe we authenticate you via OAuth, and you're a rider. So you'll have the ability to get information about new rides that need a pickup, but you wouldn't have information like the billing events and things like that coming across, or the lab result events. So we would segregate this a little bit. We would put 2 different brokers, and they'd have 2 different sets of RBAC configurations. So outside, we would have, in both places, we'd have very strict controlled regulations, but here we would not even transmit those events outside of your network. So the lab results, anything that needs to stay internal, would never appear on this external-facing broker at all, so it wouldn't be accessible. And then what does appear on this particular broker, we would control access to based on those rules, those RBAC rules.
And who is setting those rules? Publishers, subscribers, or neither?
So those are admin time rules, so you have to configure them, I guess at design time or at deployment time, and you can configure them via REST APIs on that broker. And then you can also set up queues and things like that on the particular broker and configure the access to that queue, and that would be a publisher side thing that could occur. It really depends on the exact scenario that you're looking at, but we can lock this down so that absolutely nobody could have access to these particular events. Only a few people could. We could create like a ban list and say, oh, only those people are not allowed access to these events. It's very granular in that regard.
Thank you.
Yeah. Are there any other questions?
Other question? Any other questions?
And
Okay.
If nobody wants to ask, I'll ask another one. What's your opinion about the event containing the entire payload as opposed to just being event notification? Something like, my results are available, here's the REST API, go get it.
Okay. This is a pretty big theory question around events. And he's wondering, I guess you've all heard on the mic, but what should be contained inside of event? Is it going to be entirely self-contained and have all of the information you need to act upon that event? Or is it going to just alert you to the fact that there has been a change in a system somewhere and you now have to go and via a different method assess that change and perform an action? And honestly, I suppose this could differ based on individuals' opinions, but I think that at the point that we're at with how easily accessible data is and transmission of data is, that an event can be entirely self-contained and contain all the information that you need to act on that particular event at the time that you receive it. When you have to go out and contact that system again and perform another action to get that information, you're really complicating the architecture at that point. So that would be my opinion. I'm sure others differ, but I am out of time at this point. So if you want to meet up after, we can talk about it as well.
All right. Thank you very much, Jamie. Thank you. Jamie,
Yeah,
with
thank you
Solace.
all.